Hello, this program is for hexadecimal up converter. In this program, we will try to write an assembly language which will give hexadecimal up counter, where we will start from initial count, that is 00. We will compare it for time being till 40 here. Maximum count, what we can do or what we can count from in this 8-bit counter is minimum 00 to maximum of FF, because we load accumulator with initial count 00, then the counter is incremented 01, then it goes to 02, then it goes to 03, and so on. Once it reaches 09, since it is a hexadecimal counter, we get the count after 09 as 0A, then we will have 0B, and the count continues till 0F. Once it reaches 0F, then we get 10, and the counter continues till it reaches the maximum value, 8-bit value, that is FF. This is what the program generate hex up counter will do. This program also demonstrates usage of loops, where we have jump instructions and we perform loop inside the loop. In module 1, we had seen the architecture of 8051 with different registers and their corresponding address. In module 2, we saw addressing modes, different types of addressing modes, different instructions, data transfer instructions, arithmetic instructions, logical instructions. We also had jump instructions there. So these are the examples best suited for jump instructions. What happens here is we call a subroutine named delay. Here we also come to know what is the amount of delay, how the delay is calculated in this particular programs. In this program, we can also see the effective utilization of stack, how the stack is utilized, how the program counters contents are changed according to the jump and the call instructions. Let us begin the program. I will tell you the concept of this. I will explain you the logic of this. Then the same program we will execute using 8051 Keil Microvision software, simulation software, to demonstrate the working of hexadecimal up counter. Here we load accumulator with initial count 00. We will display the count in accumulator 00. We call a subroutine called as delay. Delay is a subroutine which generates required or calculated amount of delay between the two characters or the numbers being displayed. We know that the frequency of 8051, what we use is 11.059 megahertz. When I display 00 in accumulator, then I increment accumulator. After 0, it will become 01. The change from 00 to 01 will be so drastic that we cannot make out whether it has been changed or not. So in order to recognize, in order to see, in order to read, in order to observe the transition from 00 to 11, we introduce delay. Let me go to this delay program first. When accumulator is loaded with 00, we call an unconditional delay, L call delay. So what happens when this delay is called? The content of program counter will be stored onto the stack and program counter will be changed or loaded with the value indicated by this delay, and this value is here. At the delay subroutine, R0 is taken as first counter loaded with its maximum value FF. Loop inside the loop is used for performing or generating more delay. Here, 3 registers are used loaded with the maximum count FF for generation of delay. Then the inner loop is decremented first. R2 was loaded with 00, R2 was loaded with FF. Then we keep on decrementing R2. Once it becomes 0, then we start decrementing R1. Then R1 is decremented from from FF to 00. Then finally the content of R0, which was loaded with FF, will be decremented till it reaches 00. So how fast the contents of R0, R1, R2 are decremented, and what is the amount of delay this generates? We have already discussed it in the theory classes. We can refer those theory recordings in the material to understand or to calculate the amount of delay being generated by each register. After executing this delay program, return instruction will end the subroutine. Once this return instruction is executed, here I told you the content of program counter was saved onto the stack. When return is executed, the content of stack pointer is popped onto the program counter. Then the program counter will point to this instruction. Here the content of accumulator was 00. We generated certain amount of delay. Then we incremented accumulator. Once increment A instruction is executed, 00 will be incremented to 01. Then we compare accumulator with 40. because we are starting from 0, we are ending at 40. The maximum value where I can go by incrementing the counter is FF, as I told you. The content of accumulator is compared with 40. If these two are equal, then the program halts. The execution of program is halted or stopped. So this is the main program for displaying 0 to 40, or I can go till maximum FF. And this is the delay subroutine. So this is what the program is all about. Let us simulate this program in Kill Microvision software and check the operation of hexadecimal up counter. So this is Kill software. I have just copied the program, so save the time. The same program will be saved first, then the procedure is followed by building and rebuilding the target. Once the target is rebuilt, then we will just start the debug session. Then, okay. Now the program is running. We want to see the result for counters, hexadecimal up or down counter. We go to view, then we see the result in watch windows. It may be 1 or 2. I have already selected that watch window here. I have given the value of accumulator. Then let us start executing. So the value of accumulator I have loaded with 00. Let me run the program now. If I run the program, the counter starts counting up. Initial value was 0. You can observe here, the counter is counting up. Now it is 8, 9, A. It is hexadecimal up counter, where the accumulator is incremented till it reaches the value 40, because in the program we have taken the maximum value of the count is to be 40. Once it reaches 40, then automatically the content of accumulator will become 0. Again, it will be incremented. So this is all about hexadecimal up counter. Thank you.